Hello again, this is Randy. When we say radical expressions, in a sense, we're kind of talking about exponential expressions too, because we can convert between radical expressions and exponential expressions. So today, instead of trying to simplify these expressions that contain variables, we're going to replace those variables with numbers. Let's go. So when we are asked to evaluate the following expression, what does evaluate really mean? It just means to find the value of the expression. So first things first, I think that problems like this are a little bit easier to think about if we don't have negative exponents. So let's get rid of those negative exponents really quick. Now, if we have a negative exponent in the numerator, we know that we can just move that expression to the denominator and take away the negative. So that's going to move to the bottom. And in the same way, if we have a negative exponent in an expression in the denominator, we can just move that expression to the top and make the exponent positive. Now, next step, when we have an expression on the top and an expression on the bottom that have the same exponent, we can just write this entire expression as one fraction with one exponent. So there it is, 54 over 2, all raised to the power of 4 over 3. And remember, our overarching goal in this process is to simplify the expression as much as possible. So can we simplify what is inside the parentheses? Yes, we can. What is 54 divided by 2? 27. So now we have 27 to the power of 4 over 3. How could we simplify this even more? I think it's worth trying to convert this expression to a radical expression and see if that will simplify things even more. So the denominator of the fraction that was our exponent became the index of our radical, and this 4 could go two places, and both places would be the correct placement. So one place we could put it would be as the exponent on the number inside the radical, but we can also put the 4 on the outside of this entire parentheses, and it does not change the value. In a moment, you'll see why I put the 4 on the outside and how that makes our job a little bit easier. So here it is. What is the cube root of 27? What does cube root mean? Well, it's basically asking what is x in this equation. If we have a number times itself again, we need to get 27. What is that number? In this case, it's 3 because 3 times 3 is 9 times 3 is 27. So we can replace the cube root of 27 with the number 3. You can see we're getting a lot more simplified now. Okay, very nice. Now last step. What is 3 to the power of 4? Or 3 times 3 times 3 times 3? Well, that is 81, and we cannot simplify 81 anymore. So that is the value of our original expression. It's amazing how this super complicated expression simplified is just 81. Now, this lesson is bringing together a lot of what we've learned throughout the course of this unit. So there are actually a number of ways and orders that you could have performed this entire process. So if you have a different way that's faster, I would not be surprised. And I really encourage you to try to find your own way to get to 81. The point is that we need to be careful to follow the rules that we've learned about converting radicals to exponents and exponents to radicals, as well as the properties of exponents that we've learned. Okay, let's do another example. Now, if you want, you could convert this fourth root to an exponent of 1/4 and this fourth root to an exponent of 1/4, but I don't think that's the fastest way to do this. If we have the fourth root of something times the fourth root of something, we can write all of this as one radical with the radicand 1/3 and the radicand 48 multiplied by each other inside the new radical. Now, I encourage you all the time to try to pause the video in situations where you think that you could possibly get the answer and do it yourself. Even if you think that maybe you can't, I think it's worth trying. And I believe that the students who do that really do learn more and remember the information better. So hopefully you've tried to finish this problem yourself. Either way, I'm going to continue now. So this radicand is like saying 1 times 48 or 48 divided by 3 times 1 or 3. So what is 48 divided by 3? 16. So now all we need to do is find out what is the fourth root of 16. That's like saying what times what times what times what is 16 when all of those whats are the same number, right? Or you could think of those whats as x's. So what is the value of x in this situation? Well, we could say 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is the same as saying 2. And 2 obviously cannot be simplified anymore, so that is the value of our original expression. Even though the original expression looked a lot crazier, we now know that it's simply 2. Now again, in this example, there are many ways that you could go about doing this. You could, if you want, change this numerator to an exponential expression, so it would be -5 to the power of 1/3. But I'm not going to do that because I think that it's faster to leave it as a radical and instead convert 40 to the 1/3 to a radical expression. So now we have the cube root of -5 over the cube root of 40. And if we have the cube root of something over the cube root of something, we can write all of that as the cube root of one fraction. Okay, beautiful, we're pretty close. So now we have the cube root of -5 over 40. Let's see if we can try to simplify this fraction. What is -5 over 40 simplified? Well, we could divide the numerator by 5 and the denominator by 5, and we'll get -1 over 8. Now, much like with exponential expressions, when we have a radical and there is a fraction inside of it, the radical applies to both the numerator and the denominator. So this is really saying the cube root of -1 over the cube root of 8. So let's try to find the cube root of both the numerator and the denominator. So to find the cube root of -1, we need to ask the question, what times what times what when all of those whats are the same number is equal to -1? Well, what about -1? We could say that -1 times -1 is +1 times -1 will give us -1. So the cube root of -1 is -1. Now let's find the cube root of 8. So what times what times what is 8 when all of those whats are the same number? It's going to be 2 times 2 times 2. So the cube root of 8 is just 2. So when we have a fraction and the numerator or the denominator is negative, we can write that negative in front of the fraction as if the entire fraction is negative. So that entire original complicated expression is simplified as simply -1/2. And if you think that you've forgotten some of the concepts and rules that we learned earlier in this unit, you can always look back at the visual reference guide. Now, before we finish, let me just reiterate that I really encourage you to try to find different paths than this one to get to the same answer, because there are many paths, and the more paths that you find, the better that you're going to understand how to apply all of these rules and concepts. All right, that is everything. See you next time.